Hello everyone, welcome to my channel CryptoWare, and today we are going to do some static analysis of PE files, which are portable executable files. So basically these PE files are those kinds of files which run or get executed in Windows environment. So we are going to analyze those, and currently we are in the Remnux Linux, and later I'll show you how you can perform the rest of the static analysis in Windows itself. You may not require to have a specific environment for static analysis because we do have tools, but I am currently following the way that I follow for performing these analysis. And trust me, PE file analysis, the static analysis, and at the basic level is one of the simplest one. Although you need to understand some sort of the PE structure. So let me know in the comment section below that if you want me to cover the structure in my videos, then I'll cover. Otherwise, currently we'll just move ahead with the topic. And so let's get started. And today we are going to understand some other things as well. Some will move a bit ahead, not with just the static analysis part, but we'll try to understand some important terminologies, which I have explained before in my videos as well. But today we are going to understand them in a very better way. So here you can see there are three samples, and you can see the colors are kind of different because I have created them in such a way that the permissions are different. So let's not get into that right now. So the first step towards static analysis that we every time follow is checking whether the hash is present or whether the file is malicious or not, or has ever been detected by VirusTotal previously or not. So we are going to do the same with three of the files, and we'll just perform three simple steps for analyzing it from this Remnux Linux. And later on, we'll move to the Windows machine, which we had already seen how to set up in my previous video. I'll share the link in the description below. So you can refer to that so that you can set up the environment for yourself too. So this will help us with gaining some information for performing dynamic analysis or maybe some sort of debugging which we may require. And yes, for some malware samples we do require, but we are not going to do debugging, but we are going to understand what are we going to check and what would be the approach towards debugging and why our approach will be there for, debugging this malware. And what do I actually mean when I'm mentioning that we have to debug the malware? So let's get started. So the very first thing that I'll check their hash, whether they're available on VirusTotal or not. So I'll just use this command md5 sum and I'll write malware1. And yes, I have the first hash. We'll check all of them one by one. I have VirusTotal open here and I'll just write the hash and just click on enter, and we'll see what result do we get. And 61 out of 70 scanners are mentioning that this is malicious. And from here we can see that okay, it seems to be an exe file, so we are already confirmed. And 61 out of 70, and this is Zerat. I think this is something very quite famous, and we can later on do a complete analysis of these malware which are quite famous. But before that, we need to understand some basics. So you can see that so many scanners, anti-malware scanners have detected, and it's quite interesting to see that. You can go ahead and see all the details that it mentions. You can, yes, there's some more details, that capabilities and indicators, that it runs a keylogger, .NET fundamentals it has, file is not signed. That is something very interesting. So some of the names through which they come. So these are network infrastructure, everything that you can see over here. So now the first thing that let us try to understand that what does it mean by file is not signed over here. In very simple terms, if there is mentioned that the file is not signed, so they have not used any cryptographic functions, any keys to sign the malware. So the very basic thing, why do we sign any kind of document? To prove an authenticity, right? That whether that yes, this document, this particular document is signed by me and this is authenticated. But it is not always the case. A lot of times you can, create a duplicate sign, you can copy somebody's sign so that you can prove that you are trustworthy. So the same thing goes on with these malware files as well, that yes, if it means that the file is signed, then the machine where, or the device where it is trying to get it get into, it will pose as a legitimate file and it may bypass the scanners, which is not always the case. But yes, there is one scope. There's one chance that yes, it can be bypassed. So in this case, it is not signed. So another thing, let's check some relations. There are a lot of communicating files, contacted URLs, which we don't need to check right now. We are just going through. This is something that you will be doing and you should be doing with every kind of file whenever you have been given to perform malware analysis, specifically static analysis right now, because you will be given a lot of files at that point of time and you need to check the hash. Make sure you're not uploading the files in case you're doing it for your company. So here also we can see some gibberish details and we'll get to that too, like what does this mean or why do we see everything so gibberish over here. Telemetry, community, let's check some other files, rest of the two files. So we'll follow the same method and write check for malware 2 and let's see what is it. How many detections does it have? So even it has a number of a lot of in fact detections, and this is also .exe file. Here we can see that there's written an option called self delete, which is very interesting. If you cannot see it, I'll try to improve it. Yeah, I don't know if it has helped. So it's self delete, sorry. So a lot of times what happens, some malware samples, when they get executed intentionally or non-intentionally, in case they get executed, they delete themselves. So that is one of the process they follow while they are infecting um, the other modules of your system, or maybe creating or deleting some registry keys. I'm talking specifically for Windows right now, but it does happen in other devices too. The only difference is they do not have registry keys. They have their own modules and libraries, depending upon the kind of environment we are talking about. So these things happen. So a malicious file would not necessarily be, sometimes you'll see that you just saw the file over there, you executed and suddenly it disappeared. So it has deleted itself. So maybe it has copied itself with some other name to some other folder. So a lot of times what it might have happened that the malware is not deleted. It has just renamed itself and saved itself in some other folder, and you believe it as it has deleted. Okay, so these things also happen. So it deletes itself from that specific location where you had put the malware over there, but it has moved to some other, maybe to some other folder, and from there, maybe it is trying to create some process so that it gets executed every time you restart your device. So they try all these kinds of activities. These are some kind of common things that happen. So from here also we can see some of them are mentioning it as spyware, banker, panda. We are not sure of what they are currently. So there's few details. Again, let us see. Even this is not signed as mentioned before. Affect system token, check mutex. You're not getting into those parts right now. They are quite detailed. We'll understand them. Currently, I'll be explaining only those things that is necessary for everyone at the basic level. We won't get into too much deeper because we'll be getting into that later on. And at that point of time, it will be more easy for everyone to understand. Okay, so a lot of details from here too. Let's check the content. And here also some gibberish kind of data, and we're not sure of what is it. And we're not checking everything at once. But yes, we can see some things, some interesting things. So we will check like what do they mean. And the last one that we are going to check is malware 3. Let's see how many detection does it have. Well, even it has a lot of detection. So we have 3 malicious files and they have good detections on VirusTotal. So we are kind of sure that yes, they are malicious. Let's perform static analysis and do the basics right now to understand what is happening over there. So as mentioned before, we'll use the two important commands from the Remnux Linux. One is the file and the second one is strings, because these two will give you a lot of details and a lot of information, and we will see some more information by performing another level of static analysis in the Windows machine, which you can do. You can have any approach. The basic thing is understanding the file type, understanding any interesting strings that you can find out, whether it is encrypted or not, whether it is obfuscated or not, whether it is packed or not, what is it trying to do. So these are certain things that we are trying to analyze, because based on those things, we are going to perform the next steps. So for example, if the malware sample is packed, as mentioned before, packing a malware means it is compressing and turning it into something that becomes highly unreadable for the malware analyst or the researchers to understand what is there in the malware through static analysis. So that's what we saw, that we saw a lot of gibberish values. Now that does not necessarily mean that it was packed, but there can be a chance. Now, how do you check whether it is packed or not? I'll be showing that to you as well when we will be analyzing or performing static analysis in the windows of these files. Another thing is if the file is obfuscated. So in the obfuscation, if the file is obfuscated, in that case, the file is either encoded, I mean, everything, the content in the file is in such a form that it is readable, but it is not that clear or not that visible. You can see some functions have been used, but they are also written in a very gibberish way. They are not encrypted, they are not in different form, but yes, they are in some form that you can deobfuscate, at least to a certain extent. There is a possibility to do that, and you need to have a lot of patience for that. We did deobfuscation in the previous video. We understood some sort of, where we saw that some of the content was base 64 encoded. Sometimes they use a lot of patterns and reuse the patterns continuously to make it look more gibberish and difficult to analyze and visualize everything. So that is what they do. Another thing, apart from packing or obfuscating a malware, is another thing to understand it whether it is, another option would be, is it a regular malware? Maybe there is nothing over there and you can easily see all the content. So after seeing everything from the content, if you can see the URLs they are trying to connect to, or maybe the command that they are trying to run, it gets easier for you to understand which environment and what would be the next step. Like, the environment could be understood easily through the two commands that I'm going to run. Actually, the one command, the file command, would itself be enough for you to understand what file type it is. And based on that, you can choose your environment, whether it would be a Linux environment or Windows environment. But in case the file has like you can check for different URLs, or maybe you can see that it is trying to run some command. So it is trying to run a command after downloading something from this specific URL. So you can be sure that it is a dropper maybe, or a downloader, maybe something similar to that. Maybe it is just performing or exploiting a specific CVE, maybe a specific 0-day that has recently been released. Of course, 0-day is something that is very recent, and we are talking about the recent ones only in case of 0 days as of now. So whether they're trying to do that, so these are certain things that will help you. So for example, if there is a 0-day that they're trying to exploit, and that 0-day has another dependency, which is not just Windows environment, but maybe some other applications that you all already use. So those are certain things that will help you for, while performing dynamic analysis. You need to know some of the details and most of the details that you can extract out of that particular malware. So let's check the first malware. We'll run the file command malware1, and we can see that it's P32 executable and .NET assembly mono/.NET assembly for MS Windows. So yes, it is it is Windows file. Maybe it's using .NET. So that is why it's mentioning that. So this is something that we have understood. So we need to have a Windows environment, and there should be a dependency or some supportability of .NET over there. So that is something that you can create when you want to perform dynamic analysis for the specific malware. Let's check the other malware. It is simple P32 executable and nothing else. It does not give too much detail right now. It also gives you the same details. So now we are sure from VirusTotal that these three files have been detected by most of the scanners. So these are malicious. So we have to be very careful. You must have observed right now that I have not added extension to these files, because I'll be performing static analysis of these files in another Windows machine, and that is my VM where I've installed FlareVM. Make sure you do not use them or perform static analysis in your host machine. And even if you do, of course you should not, but even if you're performing, make sure that you're removing the extension, because in Windows we know that we accidentally double click on the sample and it may get executed. So I've taken care of that. So make sure that you all too do the same, and please do not perform any kind of analysis on your host machine. Okay, so we'll check. We have checked with the file command. We'll check with the strings command for malware1. And yes, we can see some interesting details over here. Let's do one thing. Yes, so this will be easier for us. So this program cannot be run in DOS mode is something very interesting, and this is only for Windows executable that you can see. There are some other details that we can see over here. Now, if you press enter, you can keep going through all the details over here. So as of now, everything looks very gibberish. I'm just going, I'm scrolling down as soon as possible so that we can see everything that we saw before. Or we can simply quit and run it without more. So we can move ahead with the strings that were actually visible. And that is the approach that you can follow. Okay. So here, as you can see, zirat-limpy.exe is already mentioned. So we can be sure SOAP HTTP client protocol. So somewhere it means that maybe it is using, or it is trying to, connect to any server, maybe some IP. Let's see my computer, my user, keylogger. So maybe it is using keylogger. A lot of times they can be, they are a kind of distraction for you. Maybe you are just looking at all those things and this is not the actual thing that it is doing. A lot of times these happen, but that's not necessary. Let's see anything interesting that we can see right now. Registry key, Microsoft.Windows 32. So there are a lot of functions that they have used and crypto transform, create decryptor. So is there or this malware is encrypting something, the file? We can have a look. Let's see. Is there a ransomware? We're just checking. Let's see. Why are we trying to do? Because as a new as as someone who is very new to malware analysis, it is very important to understand. See here, you can see everything that it says, and let's open. Let's check what does it say. So it steals FTP credentials, writes data to remote process, reads a cryptographic machine GUID. So maybe it is not a ransomware, but it is using those decryptor or something, those functions, maybe for this reason. So it's very important that you go and check. It is not, there are a number of plenty of malware samples and you cannot remember each and everything except for few ones which are quite famous or new or you have recently worked with. So it's completely fine to look at those, you know, go and search on your own on what is it trying to say. You can also look for why this function is specifically be used. Why is it using this function? Maybe we can try to look at um, create decryptor only. Let's check. Why is it used? So it creates a symmetric decryptor object with the current key property and initialization 4. So if you see here, it has used set4, set key. So maybe it is trying to create something. We are not aware of that. And it has used a lot of functions which are currently visible to us. But we also saw that there were a lot of gibberish strings over there. So we are not sure. We cannot be sure of the fact whether it is using, is it packed, unpacked. We are going to check those things in a while. You can see username host. Now from the hash that we checked on VirusTotal, also the details that we have not even used a lot of tools, a lot of processes to understand or perform static analysis as of now. But just using these 3 steps, like not even 3 steps, just in VirusTotal and doing some sort of research on your own, we figured out that this is a kind of stealer. So it is stealing credentials. From there, you saw that it is stealing some FTP credentials as well. So host, username, password. So maybe it is trying to connect to some FTP server, or maybe it is directly stealing all those things. So here, this is a known malware. A lot of times, of course, you won't be getting a known malware. You won't be getting too much details related to that on VirusTotal. But at that point of time, file, strings command, and the later process that I'm going to show you, and also in my upcoming videos, would be helping you. So VirusTotal is something to be sure of the fact whether this file is malicious or not, or has been seen somewhere before or not, if this is malicious. So for how many scanners has it been detected? And if detected, since when, for how long is it still, active? So one thing that you can see from VirusTotal is for this, like 18 minutes ago, somebody uploaded this specific sample. And from there only, we can see that people are still checking it, and there is still this malicious file that is, getting circulated or getting spread among different people or different devices. So let's move on to the second sample. Okay, so here we can see some XML, uh, some XML related text. Sorry, excuse me. So here you can see jp2launcher.exe. So is it trying to launch it? Maybe, we are not sure. Maybe it is. Here you can see a number of commands: chmod, umask, unlink, rmdir. These are some Linux-based commands that we commonly use. But yes, this is a Windows P executable. Here is another thing: is debugger present? This is something very interesting. And yes, this is something that I would like to talk about. A lot of malware make sure or do check, they have these functions that they're using to see if they are being run in a sandbox environment or in an actual host machine. So that is the reason why they use such functions. So is debugger present is one of those functions. So sometimes they use sleep function also. So if they, just to understand whether they are being run in a sandbox environment or in a host environment or not. So if it is a sandbox environment, they won't get execute. They won't perform anything. But if they realize that this is a host environment, they will start performing their malicious activities one by one. Now now another question, or the another thing that I had mentioned initially, is why do we need debuggers? Because we need to, remove such functions from those specific files or from those specific piece of malicious code, so that we can remove this and we can analyze what that particular specific malware tries to do. Ultimately, our goal is to understand what that malware tries to do. Is it a targeted attack, or from where that particular malware has come into picture? Any specific CNC server that we can find, and what is it trying to achieve? So these are certain things that we try to look for. And if we do not remove such functions which are detecting whether the malware is being run in a debugger or not, we won't be able to analyze it as successfully as possible. So here we understood a lot of things. So terminate process. So if they understand it is being run in a sandboxed environment, or if they get an idea that they are being run in an environment where they will be analyzed, so they will terminate the process. So this is something that we came to know from here. So lock, on exit, decode pointer. There are some other interesting strings also. You can see some other functions: local alloc, get username A, create process as user A. So maybe it is trying to enumerate users. I'm not sure. I'm just guessing. So what we can do in that case is we can just look at what does this specific thing do, or does it have a meaning or not. So let's see. Retrieves the name of the user associated with the current thread. So quite interesting. So user signed into the network. So currently, who is the user? That is what they are trying to look for. So based on that, maybe they'll perform some other activity. They're reading file, they're creating process A. So they are creating process according to, a lot of times what happens, those malware samples when executed, they create another allocate another memory to them so that they can perform some other processes too. And that is the reason we look for such functions, and we'll get to that in more details when we'll be performing dynamic analysis. So load library. So even from the name of the specific functions, you can understand, or operations, you can understand what it could mean, like virtual alloc, load library. So these things are something which give you a hint that yes, this is something malicious, or at least it needs to be checked before at least running. So a lot of things that we can check. shell32.dll. You can also have a look at what is this. And why am I doing this in front of you? Because this is something everybody follows, unless they're having a lot of experience and they already are aware of these things. For beginners, for people who do not have, who are starting with this, it's very common and it's very useful and important that you Google if you don't know something, but make sure that you're not sharing any confidential data. So it is a library which contains Windows Shell API functions, which are used when opening web pages and files. So if we are talking about web pages and files, so is it connecting to some server? We are not sure of that. But that could be something that, yeah, that is something suspicious and we need to check that out later on. Let's look at the final malicious file that we have. And this is very interesting. So here we come to see some URLs too. And it looks like it is signed. So maybe it is trying to behave as if it is a trustworthy malicious file. We did not check it, like we did not observe whether it was signed or not, because for the first two files, we did see in VirusTotal that they were signed. So it looks like it is signed. And this is some URL that it is mentioning. So the first thing that I would do here is I'll just move to VirusTotal and check this URL, whether it is malicious or not. com1, com0, so they have item not found. To just remove this. So these are some basic things. So this is not malicious, even though we remember like how it was mentioned as malicious previously, right? So there is something very malicious over here, or a lot of time they're just trying to distract us or behave as if they do not have anything. So it does not show us anything interesting over here. Another thing, when you see such files, it's very important that you do not directly open them, whether they have been declared malicious or not, unless you're sure of the file and see there is no malicious activity process over there. Do not open those links. So this is something very interesting. We see a lot of URLs. These URLs seem to be genuine. A lot of times we get URLs which are not genuine, and this is something. Is it a URL? This is something very weird. We can have a look. We can check whether we can find any information from here, or maybe it is just trying to, distract us from the actual work. So let's check with this. So I don't think, yeah, it does not have much detail related to that. No problem with that. We'll see to what extent we can figure out what does it do. Is it malicious or not? Like in the previous two malware files, we did see some sort of malicious functions that they were using. The functions were not malicious, but yes, they are used for malicious activity. And yes, there's some gibberish details too over here. So we can see some functions over here too, which they are doing. They're using registry open key. So they're trying to use registry keys. They're opening, maybe trying to write something, setting value. So now that is suspicious. They are deleting some objects. So there are a lot of things, and we can see from here that they are also using a lot of functions. And that's it for Remnux Linux right now. We will check these three samples out in Windows 2. And yes, we are just performing static analysis. We will not be running those samples. So here I have my samples. all the three samples over here in my FlareVM, and I'll just use simple methods. I won't be using a different kind of thing. And here we are going to understand how to understand if these malware samples are packed or not. And that is very important. And that would be one of the factor. Of course, that is not the only factor. There are other factors also. I'll be mentioning them also, but I'll be talking about one specific factor that we had discussed previously in my very first videos when I was explaining about different terminologies. So I will look for PE Studio. I'll open PE Studio. And yes, we'll start with malware sample 1. We'll open the file. And we have sample over here, and we'll start with sample 1. Now, this virtual machine of mine is not connected to the internet. So that is why VirusTotal shows offline over here. If you're connected to the internet, you will be seeing all the VirusTotal results that I just now showed you in the Remnux Linux where I'd opened it. And you can see it is analyzing it. We can figure out all the information that it is giving. So currently, the details that we have over here, so all the details that we have are MD5, SHA, MZ. So a PE executable files generally have their magic headers as MZ. Now, what is magic header? So any kind of file that you can identify the type of their files using or checking magic headers. We are simply using the file command from the Remnux Linux or any other Linux machine. But they also check for these magic headers that give you an idea of which file type is it. So MZ is for Windows. So here we are not going to do a lot of things. This is one tool that is going to give you all information. Entropy. Now, what is entropy? And we can see that the entropy mentioned over here is 7.883. Now, this entropy is one of the most important factor for us to understand if it is packed or not. So if this file is packed, the entropy would be high. So entropy of a file is defined between 0 to 8, I guess, and 8 being the highest. So here it's 7.883. So it is very highly packed. Now, packing of a malware means, as I mentioned, that turning it or compressing it into in such a form that it is not even readable. It is very encrypted and very gibberish, that it is not even clearly understandable to the researchers or to the malware analysts. So in that case, they have to unpack that malware to get the actual malware so that we can analyze. Now, to get that actual malware, a lot of times some malware authors use already existing softwares which can pack these malware. And since these are already existing or maybe free open source kind of packing softwares, so we can easily unpack them as well. For example, UPX is one very common packing software or the method that they use. Sometimes malware authors do use their own ways or different ways which are not, which are not very common, which are not present, like if it is packed, and how to unpack such kind of samples, which is not a very common way to unpack them. Then in those cases, we have to use some debuggers, and that is the reason why do we need another method before performing dynamic analysis. Now, see, if you want to perform dynamic analysis, you can do. But in one of the sample, we did observe that there was a function that was used to check whether the malware is being run in a sandbox environment or not. So in those cases, there is a middle ground and there's an middle step that we need to follow. And we will be doing that also later on. First of all, let's get acquainted with the basic things right now, how to perform. At least let us understand how to see if a malware is packed or not. So here we can see that it is packed. Some more description, Microsoft.NET entry point that you can check when we will be performing debugging. At that point of time, entry point might be a good thing to know. That would be helpful. Compiler stamp, you can see some other information. Let's see some indicators. Now, indicators of compromise means those factors which are making it very clear to us that yes, this is malicious or at least suspicious. And yes, we can figure out a lot of things. And we did see they are also checking the strings. So they are also not doing, these tools are also not doing anything very different. So checking file, for understanding the file types, we generally look for the magic bytes. So the file command mentioned in Linux or Remnux Linux is not doing anything very different. It is doing the same thing that we are trying to do. Here also it is analyzing the strings which are visible, because if it has high entropy and it is packed, it is difficult and highly impossible for these tools also to give us a lot of information. In those situations, we need to perform some steps manually, unless they have used a very common software to pack the malware. Otherwise, the things have to be done from our end only. So we can see a lot of indicators. So these also indicate. So instead of going to VirusTotal, file, strings, you can simply run that executable file, not run, sorry. You can simply open it in PE Studio and you can see all the indicators. You can, if you are connected to the internet, you will be able to see the VirusTotal results. You do not have to check everything. DOS header. So you can see, I'm not going to explain this. The DOS headers entropy is this. So maybe that is why we were able to read some of the things. DOS stuff. If necessary, let me know. I will be explaining the piece structure because we take a lot of time understanding the how to do analysis of a malware itself. So it does take a lot of time in itself. Optional headers, some directories. Another thing that I want to mention over here, you can see some libraries over here. Another thing that is very important to notice is, apart from high entropy, a malware is not just a very small piece of code. If the malware is supposed to, disrupt the entire service, and it is a huge malware which is performing some key logging or maybe performing some cryptographic functions, then it should not be just using these three libraries. So usage of very few libraries also indicate that maybe this malware is packed and we need to unpack this malware just to see if they're using any other libraries, and of course they will be using. But currently, the less number of libraries also show us. We can see some functions, and again, we saw these functions using the strings command, right? So we are not doing anything very different, but yes, we figured out some very interesting things. Set keylogger, they have set some of the very common processes under blacklist. Download file, so it is downloading something, it is creating some API. So there are a lot of things. Some of the functions are, of course, because there are three libraries that we saw. .NET type build. Sorry, this is typely build. Anyway, so there are some other details also. So the strings that we saw at that point of time, that is also visible. So from here only, it has indicated that which could be the indicators of compromise, which could be a suspicious function that they're using. From here only, a lot of times you figure out some URLs, but that is not it. There is more to it because it is packed, and it's very sad to know that I'm not going to unpack it right now because we'll be doing it later on. I'll make sure that this malware sample is over there before unpacking them. So let's try and analyze the rest of the two malware samples and see if they are packed or not. So this is quite easy as compared to the rest of the files, I believe, that we have observed. It is already analyzing. Let's see if we can run another one. If we can open another one. Till the time it is analyzing, we can open and we can check both of them together. And we'll be using malware 3. So let's check malware 2. And here the entropy is slightly lower than before, but it's still on the higher side. So it is packed 2. Indicators, there are 41 indicators that we can see from here. Some libraries, so there are only 4 libraries that we can see. So the number of libraries is also less. But there are a lot of functions that we can see which have been blacklisted, and we are kind of sure that yes, it is malicious. The strings that we have seen before, so against them also it is mentioned. So why it is a better one for all of us, because it gives us an idea also that which specific function has already been blacklisted by this specific tool. So we can have a look and we can have a guess and check whether this is malicious or not. So we can be very, clear to that. We can be all sure of that. I'm not going ahead with a lot of things. I'm just showing you some basic things because the common things that we have already seen. Again, this is for the third malicious file, and there are 64 indicators right now for this file. And let's check. There are 12 libraries. So there are some libraries that we can see, and some of the libraries have been blacklisted. So let us check whether how much entropy. So even its entropy is kind of high, but we can see some libraries. So if it is packed, there are more libraries, but some of the libraries have already been blacklisted. So as you can see, there are a lot of things that we can see, we can observe, and that is quite interesting. And we can gradually, after gaining all these information, we can gradually move ahead with the dynamic analysis part 2. And I hope you have understood why debugging is important. Why do we need a debugger before performing dynamic analysis? Even for performing dynamic analysis, we need debuggers a lot of times, especially for real world malwares, because these are some actual malware and these malwares are always packed. So it gets very difficult for us to analyze. So that's it for today. We'll see you in the next video, and we'll see what we can cover in the next video. We may start with dynamic analysis or static analysis of some other file. Let it be a surprise. So thank you so much. See you in the next video. Please like, share, and subscribe to my channel, and see you.